Hello, welcome back to the second part of week 5 from the ECE9013 course. In this part, we are going to discuss what are lists, how to define them, and some of the possible operations that can be applied to lists. Lists are ordered sequence of information accessible by index. A list is denoted by square brackets and it contains elements, usually homogeneous. That is, for example, all integers, all strings. It can contain mixed types, however, this is not common. Note that list elements can be changed, so a list is mutable. This is in contrast to the previous part in which we discussed tuples and mentioned that tuples are immutable. As an example, assume we have the list L defined as follows with multiple elements of different types. Note that here one of the elements is a list in itself. So the length of L would give us 4 because we have 4 elements in L. L at 0 is 2. L at 2 plus 1 would give us 5 because this is L at 2. So this is L at 0, L at 1, L at 2 plus 1 gives us 5. L at 3 gives us another list. Here L at 4 gives an error because there is no element at that index. So here, for example, if we define I to be 2 and then we use the index L at I minus 1, it would evaluate to A because L at 1 is A as per the list above. As we mentioned, lists are mutable, which means that we can assign to an element at an index is possible and it changes the value. So for example, if we have the list defined as follows to be 2, 1, 3, if we say L at 1, which is the index of this element, and set it to 5, L is now 2, 5, 3, and this is the same object L. For lists, we can actually compute the sum of elements, assuming that all elements within the list are numbers. And again, we can iterate over list elements. So for example, in order to get the sum of all elements within a list L, we can define a variable total to be a 0, and then say for every element I, in the range of length of L that we would like to add to the variable total the value within the list L at index I. So in this case, I is iterating over the indices of the list L. And finally, print the total. Or we can do it by iterating over the elements of L. So in this case, we say for I in L, total, add to it the value of I, because in this case, I would take the value of the element itself rather than the index. Notice that the list elements are indexed from 0 to length L minus 1 because, as we mentioned, indexing in Python is done starting from 0 to the length minus 1. So the range in this case would go from 0 to n minus 1. It is possible to perform list concatenation using the plus operator. So for example, if we have list L1 and list L2, this operation would actually result in a new list L3, which is the concatenation of both. However, note that in this case L1 and L2 are the same. They have not been changed. Some other operations possible to be applied to lists is the append, which is basically adding an element to the end of the list. So for example, if we have L1 to be as follows, if we type L1.append 5 and close the parentheses, L1 would be 2, 1, 3, 5. We can also extend a list, and then again we can extend the list by adding another list, and this is similar to the plus operation. So in this case we would add a sublist of size 2 to L1, and this makes L1 become as follows. We can also actually delete an element at a specific index using the DEL operator. So delete or DEL of L at that particular index deletes the value at that index. Lpop removes the last element from the list and returns this element. You can also specify lremove element. So it removes a specific element within the list. Note that this operator, remove, removes only the first occurrence of the element in case the element exists multiple times within the list. If the element is not in the list, this operator would result in an error. These are examples of these different operators. So we can see we defined L as a list, then we remove the element at 2, the element 2, so it removes the first element, now L becomes as such. Then we remove element 3, so it removes the first occurrence of this element, which is this one, that's why now L becomes as such. We can then delete the element at index 1 of L, which is 6. Now the new list becomes as such. And finally, by applying this command, it returns the value 0 because it's the last element of the list, and now L becomes as such. Note that you can use casting to transform strings to lists. So if we apply the command list of S, it converts the string S to a list and returns a list with every character being an element in L. We can then use s.split to split a string on a character parameter, and if we don't specify what character, it splits on the space. There's also the .join of L. So to turn a list of characters into a string, we use the join command from string. So here, for example, if we have S, the following string, where S is a string, when we implement list of S, it returns a new list with every character being an element. S.split on this character would return a new list split based on that character before it and after it. Now here, if we have L to be this list of characters, we can join this list into one unified string, and this will return this string. Or we can define a new character to be the separator between the elements of the list. So if we here use the underscore, this is the output. Other possible operations include sort and sorted and reverse. Sorted returns a sorted list but does not change L. L.sort changes the list L into the ascending order, and L reverse sorts it in the decreasing order. So as we mentioned, lists are mutable. They behave differently than immutable types. A list is an object in memory with the variable name pointing to that object. So any variable pointing to that object is affected. So key phrase to keep in mind when working with lists is the side effects. Thank you.